All right, so this is the final investigation of this book, Solving Systems by, they call it combining equations. It's also been really formally called, you want to turn off your conversation, please? Or you can do this? Elimination. So I want you to write that underneath. That's the word that it's commonly referred to in most math textbooks. So basically, it's using addition or subtraction to eliminate a variable, and we're going to kind of get in how to use it. So the first part here says use the methods of Pablo and Jasmine and Samantha to solve each system. Well, that's on page 30. So it says Pablo and Jasmine showed their method for solving systems for linear equations. Their teacher then asked the class how you could solve the following system using the methods from problem 2.0. Now, we skipped problem 2.2, but the problem is 2x minus y equals 4 and x plus y equals 5. And what they did is they saw a minus y and a plus y, and if you add those together, don't they cancel out? So they said by adding these terms, we could cancel out the y, solve for x, then plug it back in. Kind of like you did in substitution. So Pablo said, Jasmine and I combined equations by subtracting equals from equals. So same numbers. Samantha said, in my method, I combined equations by adding equals to equals. Okay. So we're going to try to use both methods in these 4 examples to show you how basically the elimination method works. Now, usually with these 2 methods, most people either prefer substitution, which after the last quiz and stuff, I don't think anyone here does. Most people also like this method. They say it's a little easier. So when we say equals to equals, all right, in 2.1 we try to substitute out a variable. And here we're trying to eliminate a variable by using addition or subtraction. Okay. So you're trying to look for variables that have the same number. So 2 and 4 aren't the same number, right? Correct? But 1 and negative 1, they both have a 1, right? One's positive, one's negative. So if we add these 2 equations together, negative 1 plus 1 equals what? 0. And that can form our elimination. So what we're going to do is we're going to add both equations together. Now in the book, the examples work horizontally. We're going to work vertically because you're used to working vertically. So when I take negative 1 plus 1 or negative x plus x, that's 0, right? That goes away. 4 plus 2 is, so we're left with 6y equals 7. And when I divide by 6, y equals 7/6, or 1 1/6, or, oh, what's my decimal? 1.6 repeating? 1/6 repeating. Okay. So you see how much quicker we can find one of the variables? Other than substitution, where you had to go through and put them in y equals mx plus b, substitute it, set them equal to, go. It's kind of quicker how we found it, right? Now the same idea is we're going to take this y that we found, probably use the decimal would be smarter, and we're going to plug it back in to the original equation. We'll pick any one of them you want. So, oh, let's see. Kelly, which equation would you like to use? Top one or the bottom one? Bottom one? Okay. So, where y is, we're going to replace y with 1.16 repeating. Okay. So, two times 1.16 repeating is 2.3 repeating. And then I'm going to subtract it to both sides. So I can solve for my x. So, 5 minus 2.3 repeating is 2.6 repeating. So I found my x and I found my y. Pretty quickly too, right? How much faster is this than substitution? A lot, isn't it? So, what do you think we got to do now? What did we do in substitution when we found both points? plugged it back in and checked it. So we're going to use the other equation we didn't use to check it. Okay? Here, we'll do this in blue. So, so up top, so negative, and then 2.6, repeating, plus 4 times 1.16, repeating, needs to equal 2. Well, 4 times 1.16, repeating, is, that's 4.6 repeating, and that's negative 2.6 repeating. And when I take negative 2.6 repeating and add 4.6 repeating to it, I get 2. It checks. So again, how do we write our final answer? As a coordinate. Because this still shows the intersection point using a different symbolic method. So you still need to write it as a coordinate. And your final answer would be 2.6 repeating and 1.16 repeating. How many people kind of like this method already better than the other one? Lots of hands, okay? All right, let's take a look at number 2. Where do we have a like number? The y's, right? Now, what do you notice about the y's? That's different than number 1. Number 1, the like number was the x's, right? But what was different about the x's? Signs, right? Positive, negative. What do you notice about number 2? They're the same thing. So what do you think is going to happen when we have the same number and the same sign? Here, number 1, we had the same number but different signs, and we added. What do you think we're going to do here? Subtract. Boy, you guys are smart. We're going to subtract. Now, this is where you have to be careful. We know that 3y minus 3y is 0. So we're going to eliminate the y's. So now, we got to just go in order. 2x minus 5x. So what's 2 minus 5?
Excuse me, can Jenna write?
Okay. So we said it was negative 3x. All right, William, can you get the door? Now, this is kind of what you have to be careful of. Look, when I go past the equal sign, I have a 4, and we're going to subtract negative 8. What happens when we have a double negative? It's a positive. And this is where you got to be careful, okay? So you really got to just kind of think that out. Don't just look at it and go, oh, 4 minus 8 is negative 4. Okay? This is double negative, so this is actually 12. Okay? So we have eliminated the y. We're going to solve for x. Divide both sides by negative 3. And x is negative 4. All right. Joe, which equation do you want to plug negative 4 into? Top one? Okay. So, we're going to solve for y now because we found our x. We're going to solve for y. So, we have 2 times negative 4 plus 3y equals 4. And now we're just going to solve it out. Okay? So what is 2 times negative 4? Negative 8, right. Plus 3y equals 4. We're going to add 8 to both sides. So we get 3y by itself. And we get 3y equals 12. So when I divide by 3, y is what? 12 divided by 3? 4. All right, so I have my x. I have my y. Right? What's the last thing we need to do? Check in the other equation, right? So since we plugged the first one into the top one, we're going to plug both points into the bottom one. So 5 times x, which is negative 4, plus 3 times y, which is 4, equals negative 8. So 5 times negative 4 is negative 20. 3 times 4 is 12 equals negative 8, and we end up getting negative 8 equals negative 8. It checks. So our solution is negative 4, 4. So you've seen one reason why we've subtracted and one reason why we've added. Same number, same sign, we subtract. Same number, different sign, you add. It's whatever gets you to 0 to eliminate that variable. Making sense so far? Yeah? Better than substitution? All right, take a look at number 3. Are we going to add or subtract? How many people thinks we're going to add? Raise your hand. How many people think we're going to subtract? Okay. Why? Well, there's negatives right here. Same number, same sign. We subtract. Okay. And again, the common mistake is to say, well, let's add. Well, here, let me show you. So same number, same sign, we subtract. Because when you take negative 3y minus negative 3y, you got the double negative, right? Which becomes, and adding it, which gets to 0. So what's 2x minus 5x? Negative 3x. And then 4 minus 7. Negative 3. So again, we've just eliminated the y to solve for x. That's where the word elimination came from. All right, so to solve for x, we got to divide both sides by negative 3. Okay, and we get x equals 1. Well, that'd be nice and easy to plug back in, huh? Brad, which one do we want to plug it into? First one? All right, so we're going to replace x with 1. So 2 times 1 is just 2. Minus 3y equals 4. And we are going to subtract 2 to both sides. And I get negative 3y equals positive 2. And when I divide by negative 3, I get y equals negative 2/3 or negative 0.6 repeating. All right, so now we're going to take that and plug it into the second equation, right? Okay, so we're going to take both of these and plug it back in. So 5 times 1 minus 3 times negative 0.6 repeating is going to equal 7. Well, 5 times 1 is 5, right? That's a nice, no equal sign there. All right, so if I take 3 and I take it times negative 0.6 repeating, oh, I hit the add button. That's not going to work. You should get negative 2. And again, if you just plug the fraction in, 3 times negative 2/3, right? Cancel out. So I got a double negative, right? Which means positive. So we get 7 equals 7. So we got the right answer, don't we? Our coordinate is 1 and negative 0.6 repeating. Okay. So far so good, right? Look at number 4. Let me make a little line here. What's special about number 4? Yeah, there's no same number or different or same sign, right? So, remember, it's probably say it with symbols. Remember, we had lots of practice making equivalent equations, right? We had to multiply things to an equation to change it, or so. This is what we're gonna have to do here. Take a look. 3 can't go into 4, or 4 can't go into 3 evenly, right? No. However, 2 can't go into negative 1, but negative 1 could go into 2, right? So we have opposite signs here. So if I take the second equation and multiply the whole thing by 2, I'm going to end up with a negative 2y, right? Which means what? Same number, but different sign. So I'm going to create an equivalent equation so we can have an elimination. Okay? You're going to use that when you don't have that nice, easy, same sign, same number, or different number, or same number, different sign. You're going to find which number can easily go into the other one. If you use this one, you'd have to multiply both equations. Okay? Which is another option, too, as you come down the road. Sometimes you're going to have numbers that don't work for both, and you just got to find a common multiple to get to it. So this is multiplying just one equation. So we're going to copy the top one, okay, because we don't need to change that one, right? And now I'm going to take every single term in that second equation and multiply it by 2. So what is 4x times 2? 8x. And then 2 times y is 2y, and 6 times 2 is 12. So now I've created an equivalent equation, right? Because I can take this and divide everything by 2 and come up with this original equation, right? So it's still the same ratio. So now what I can do is now I can eliminate, though, right? By doing what? Adding or subtracting? Adding, right? Because we have different signs, same number. So if I add these together, 3x plus 8x is good. And 10 plus 12. And when I divide by 11, x is 2. Okay. All right. Nolan, which equation do you want to plug the 2 into? Top one? Okay. All right, we can go over here. So 3 times 2 plus 2y equals 10. So 3 times 2 is 6, right? And I got to move the 6 over by subtracting. So I'm left with 2y equals 4. And I get y by itself by dividing by 2. And y should equal 2 also. So we have the point 2, 2. So let's plug it into 4x minus y equals 6. And if that works, we have the right answer. We found our solution to the system. So 4 times 2 minus and y, so it's 2, equals 6. Well, 4 times 2 is 8. And when I subtract 2 from 8, I get 6. So 2, 2 is our coordinate. Not too bad? No, not too bad at all. Okay, so this was a good warm-up to kind of show you how elimination works. All right, so let's answer B. It says in the T-shirt and cap sale, the equation 5S plus 10C equaled 125. Related profit to the number of T-shirts and caps sold. Okay, here's what I want you guys to take just a couple minutes to do. I'm going to give you 5 minutes. I want you to find, number 1, I want you to find the 5 solutions of that equation. Meaning there's 5 coordinates that could make that true. Remember, we've had lots of practice doing that, right? Especially in the graphing. We did the graphing. We found the coordinates that made that equation true. So I want you to find 5 coordinates that make that equation true. And then we'll come back and see how you did. All right, so we're going to pause the video. All right, what was one of the points that you could use? How many people use the intercept? Put a 0 in for something. Anyone? Nobody? Nobody put a 0 in for something? Right? If I put a 0 in for S, C is what? What's 125 divided by 10? 12.5. And if I did it the other way around, 5S equals 25, you could do 25, 0. So there's 2 right there. Anyone want to share a point? Andrew. 25 and 5. S is 25? I think it's a little big, right? Because 5 times 5 is 125. If I do 5 times 10 is 50. Yeah, you're at 175. Remember, you got to make it equal to 125. You got another point that worked? That's still too big. This is 25. So 5 times 5, that's 125. And that's 100. You get 225. That doesn't equal 125. 19 and 3? What's 19 times 5 is 95. Okay, yeah, 95 and 30 is 125. All right, so 19 and 3 could be a solution. Good. Brad? 5 and 10. Yeah, because 5 times 5 is 25. 10 and 10 is 100. So there you go. Jacob? 10 and 8. You said 10 and 8? Well, if 10's here, that's 50. This is 80. What's 50 plus 80? You're 5 over. William? 11 and 7? Yeah, 55 and 70 is 125. So 11 and 7, good. Katie? 5 and 15. Well, 10 times 15 is 150. 15 and 5? 75 and 50, yeah, okay. Yeah, order is important there, right? Because if I flip it the other way, it doesn't work, right? Dana, give me one more. I'll give 7. 21 and 2. Okay, 105 plus 20. 21 and 2. All right, so you got the idea, right? All right, so number 2 says, so Samantha says if we had doubled the price of each item, okay? Remember, the original equation was this, right? $5 a profit per shirt, $10 a profit per the cap, and it was $125 profit, right? So she said if we doubled the price, we would have doubled the profit for the same number of shirts and caps sold. Do you agree with her reasoning? Why or why not? So she said if you doubled the price, basically multiplying it by 2, would you have doubled the profit? Yeah, if you make $5 in profit off the shirt and $10 off the hat, so you take that price and double it, then you're going to double your profit, right? So if we doubled it, if we double this equation, what do you think in number 3 our new equation would become if we double this? Which means what? We'd have to multiply this whole thing by 2. So what's 5s times 2? 10s. And then 10 times 20c equals what? 250. So yeah, if you doubled your price, we double our profit. Make a lot more money. All right, getting near the end here. All right, so look at it says, and see it says, is system B equivalent to system A? Explain. So let's look at these two equations. Are they equivalent? Yeah, they're actually the same, aren't they? So same equations can also be equivalent. Right? These are the same. What about these two? Are they equivalent? Are they equivalent? I heard a yes come from somebody. Why is the reasoning yes? You just multiplied system A by 2 to get system B, right? So yeah, this is multiplied by 2. So yeah, they are equivalent. That's just like we did just right up above, right? So it says use the combination, which basically means elimination. I hate that they changed this name, like they think they invented this. Elimination to solve. So let's solve this system in B. So 2y equals 10 and 8x. So what are we going to do? Are we going to add or are we going to subtract? Where do we have the same number? And then check your signs. How many people think we're going to add? How many people think we're going to subtract? Okay, that's like 8 people who said something. It's the same number, opposite signs, right? Which means we add. Because when you add negative 2 to 2, you get 0. So here you get 11x equals 22. Isn't that the same as the one on the front? It's exactly the same as the one on the front, number 4. And when we divide by 11, x equals 2. So when you plug it in to the original equation, which is basically system A, right? Because we don't want to double this. So let's just go, I think we plugged it into the first one, right? So 3 times 2 plus 2y equals 10. That's 6. Right? Same thing that you had there on the front for number 4, right? 2, 2. So then if I take it into my new equation for system B here and plug both of them in, 8 times 2, oops, that's not plus, minus 2 times 2 equals 12. So 8 times 2 is 16. 2 times 2 is 4. 16 minus 4 is 12. So yeah, 2, 2 is a solution to this. Well, now it says check your solution so also satisfies system A. Well, we know the very top one, it satisfies, right? Because we just checked it here, right? I mean, I guess we can humor them if they want to. 3 times 2 plus 2 times 2 gives you 10. And we also got to plug it in for, because remember, it's got to satisfy both. So this is 6 plus 4. And 6 plus 4 equals 10, right? So that's one of them. And this is 8 minus 2, which is 6. So it does satisfy both of them, doesn't it? And the only reason it can is because they're equivalent equations. If they weren't equivalent equations, there's no way it could satisfy both of them. All right. Moving on to our last part here. We'll see how much time we got left. You may have to finish this video at home. There is a homework assignment, by the way. Number 1. How are we going to solve number 1? Do we have an equivalent? Yeah, we don't have an elimination right at the bat, right? We don't have an equal. We don't have equals. We don't have same numbers, same sign, or same numbers, different sign. So that means we got to change one of them. We got to come up with an equivalent equation, right? Which equation do you think is going to be easier to change, the top one or the bottom one? Top. Why would you say the top? Okay, because if I do 2 and 3, I got to change both of them, right? But if I do the y's, 2 can go into 6 evenly, right? What would I multiply the top by so we can get an elimination? 3. 3 is good because we can change it. We have a sign. Or you could do negative 3 and subtract. Either way, you can't go wrong either way. So, all right, we'll multiply by 3. So if we change the top, multiply every term by 3. So that should be 6x plus 6y equals 15. And then I got 3x minus 6y equals 12. We'll copy the second one. So am I adding or subtracting? Adding, because we have same number, different sign. So by adding, that goes, right? That becomes 0. So what's 6 plus 3? 9, 9x. And 15 plus 12? 27. And when I divide by 9, x is 3. Okay, so now I'm going to take that and we'll plug it into an equation. Mind you, which equation you want me to plug it into? Top one? So 2 times 3 plus 2y equals 5. So we got 6. And when I subtract 6, (2y) equals negative 1. So I get negative 1/2, right? Which is also negative 0.5. So now we just plug it into the second equation, and if it checks, we're good to go, right? So 3 times 3 minus, probably should have just went underneath it, eh? Well, running the other problem up here. So 3 times 3 is 9 minus, and then 6 times negative 1/2. Anyone got plugged in a calculator? 6 times negative 0.5. Negative 3. And since I have a double negative, 9 plus 3 is 12. So that checks, right? So my solution is 3, negative 0.5. All right. Number 2. Do we have anything up there that has same number and same or different sign? No. So we got to change one or both the equations. Which variable would it be easier to eliminate? X or Y? X, right. And this is your thinking. You got to say this. Can 1 go into 4? Yeah. You're only changing the 1 here. We're here, 3 can't go into 5, or 5 can't go into 3. So for you to get an elimination here, you would have to change both of them, right? One would be 5. You'd multiply that by 5. You'd multiply this by 3. So you get the same number. Here, if you only have to do 1, right? Do less work. You can get the same thing done with less work, right? So we have to multiply the top equation by what? If this is x and this is 4x, we want the same number, 4. Very good. So if I multiply the whole thing by 4, I get 4x plus 12y equals 16. And let's copy the second one. Okay, am I adding or am I subtracting? Because we have the same number and same sign. So 4x minus 4x gives us 0. And that's what we want. We want that elimination. So this becomes 7y, and 16 minus 2 is 14. And if I divide by 7, y is 2. All right. Joey, which equation do we want to plug 2 into? Top one? Okay. So we'll have x plus 3 times 2 equals 4. So that's 6. And when I subtract 6 to both sides, what's 4 minus 6? Negative 2. All right, so now that we found both parts, we got to plug it into the second equation to make sure it checks. That's the similarity to substitution, right? When we found both points, we had to plug it into the other equation we didn't use. So 4 times negative 2 plus 5 times 2 equals 2. What's 4 times negative 2? Negative 8. 5 times 2 is 10. And negative 8 plus 10 is 2. So it does check. So our solution to that system is negative 2, because that's the x, and 2 is the y. How are we doing so far? All right? Feeling pretty comfortable with this? A lot more than substitution? All right, let's look at number 3. This is probably going to be our last one together. I'm going to have to probably finish this video when the class ends. But look at number 3. Okay. We don't have any same number, same sign, or different sign, right? So what variable is going to be easier to eliminate? Right, because again, 2 can't go into 3, 3 can't go into 2, but 1 can go into 2, right? So we're going to multiply the top equation by 2. So 4x plus 2y equals 10 becomes the equivalent equation when we multiply that top equation, every single term, by 2. And now we're just going to copy the second equation. Not going to change anything. So now, adding or subtracting to get our elimination. Adding, because we have the same number, different sign. So when we add this, this goes away, right? Negative 2 plus 2 is 0. So this becomes 7x equals 25. Oh, we're not going to get a nice number here. So this is 25 sevenths, which could become, what, 3 and 4 sevenths? Or 3.571428, right? Okay. So the decimals have reared their ugly head, right? All right. Where do we want to plug this into? Top one? Okay. 2 times, and we're just going to call this 3 point. I'm going to try to write this as small as I can because I don't have a ton of room over here. Plus y equals 5. All right. So when I multiply that by 2, I get 7.142857. And that repeats. Equals 5. So when I subtract that number, I'm just going to save myself the writer's cramp. 5 minus 7.142857. We get 2. And it's negative, I believe, right? Yep. Negative 2.142857. So if that's y and that's x, and see, you guys should be pretty good at the decimal thing already because we had lots of practice. We're going to plug it into the other one. So we used this one, right? No. Which one did we use? We used the top one. We got to use the bottom one, right? So 3 times this minus 2 times this equals 15. Well, okay. So this is 10.7142857. Nope, I wrote that wrong. 1471428. Yeah, that's right. It repeats after 5. That's why I don't need the 7. And this becomes a plus 4.285714. When I actually add these together, you get 15. So our crazy coordinate, which is a lot of decimals, but you would understand the fraction because they're all sevenths, is this. All right. So I'm going to pause this for right now. Okay, so we are going to finish up the last problem here. All right. So there's two ways we can do this for number 4. Um, you could eliminate x or you could eliminate y. Um, so we're going to multiply by 5 because something special is going to happen here. When I multiply by 5, I get negative 5x plus 10y equals 25. Okay? And when I'm going to copy down the second part because we didn't change that. So watch what happens here. I got same number, opposite signs for both variables. So when I add, this goes away. This goes away. I'm left with 0 equals 36. Okay? Remember when we did substitution, we had those two special cases where if the left side equaled the right side, that's infinitely many solutions. And if it didn't equal, no solution. Well, 0 does not equal 36, which means there's no solution for this system by substitution. It's not an identity. Okay? If there's no solution, that means these two lines are parallel, right? So if I were to take negative x plus 2y equals 5 and put it in slope-intercept form, watch what happens. So I get 2y equals x plus 5. Because remember, parallel lines are same slope, different y-intercept. I get y equals 1/2 x plus 5 halves, right? Well, if I do the other equation and do the same thing to it, by our no solution, we should end up with the same slope again. So let's see if that happens. Negative 5x, and I get negative 10y equals negative 5x plus 11, and negative 10. So y equals, and negative 5 over negative 10 is 1/2 x. And then it's going to be minus, not plus. But the y-intercept doesn't matter because it's different. Minus 11/10. So again, you have same slope, but different y-intercepts, which means the lines are parallel, which means you can't have a solution. So I hope you find the video for elimination helpful. The homework assignment is right here. And on page 34, you're only doing 23 to 31 odds for that part. So again, hope you found this video helpful.